Welcome to this video on the topic of vectors. In this lesson, we're going to have a look at the magnitude of a vector, that being the length of a vector. This video will be split into three sections. The first part being we'll have a look at why the calculation works and how it operates. Secondly, we'll do a few examples of how to do the magnitude calculation by hand. And then finally, we'll have a look at how we can use our technology to do the calculation for us. Okay, to begin, magnitude of a vector simply describes its length. Magnitude may be calculated using Pythagoras' theorem. So if we observe down just below the text, we have an arbitrary vector x and y. We'll just call it vector OP. The magnitude of the vector is found by simply stating the vector inside these parallel pipes over here. So this says we want to know the magnitude of vector OP. Now if we go down, we simply see that we get a very familiar looking calculation, this being Pythagoras' theorem. Now the reason this works is if we observe the diagram over to the right here, we can see that we have the origin and the position P that's in some place in space over here. It's got coordinates x and y. Because we're looking at between the origin, what we find is that x over here is going to denote this axis here. So x, and then you've got y doing the vertical. And these guys are always opposed at 90 degrees. So for that reason, we simply form a triangle, and therefore the length of the vector over here can be found by just applying Pythagoras' theorem. So that is why when we're doing the magnitude of a vector in space, all we need to do is throw it inside of Pythagoras' theorem to calculate the magnitude. So let's have a look at how we can put this to use. Consider we have example A. Vector A is defined as 3 and minus 4. What we would like to do is calculate the magnitude. To do this, what I'm going to do is I'm going to get vector A and I'll write it out like so. And I want to get the magnitude, so I'll show I'm getting the magnitude by putting it inside the modulus symbol, so these two parallel pipes. This can be formally written as 3 and minus 4. If you really want, you can draw the square brackets like that, but you don't need to if it's already inside the modulus like shown over here. Next, we can convert this directly into Pythagoras' theorem. So I get 3 squared plus minus 4 all squared, and it's all square rooted. Doing the calculation, I get 9 plus 16 all square rooted. Notice that the negative went away. Then we're going to get 25 square rooted, and then we're going to get 5. And because this denotes a length, typically speaking, we will say that it's 5 units in length. There's no units specified, then just say it's 5 units. So this was a manual calculation of the magnitude of vector A, which was defined as 3 and negative 4. This is in column vector form, also known as component form. Now let's look at B. We have vector B. It's defined as negative I plus 3j. Notice that this one over here is in unit vector form. Now just because this is in a different form doesn't mean we can't do anything with it. Rather, we can just run it like it was before. So we're going to have negative I plus 3j, and all of these are in the modulus symbol because we want to find the modulus of vector B. To do this, I'm going to split it such that I'll get the x component, which in this case it's minus 1. And I'm going to square it. And then I'll get the vertical component, or y component, which is 3. And then I'll square that. This has all been square rooted. So I can go from this line to this line because the modulus symbol means I'm going to apply Pythagoras' theorem to it. Next, I do the calculation. It's going to be 1 plus 9. That will be root 10. And if I want, I can say that the modulus of vector B is equal to root 10 units. Or if I really want, I can give an approximation of that. So I'll say up we come to the calculator. Number 1, shift square root 10 equals SD, and it's 3.16 to 2 decimal places. So here's my answer here. I don't mind leaving it at that though. So this was the manual calculation. When we're dealing with component form, then all we need to do is we get the x and the y components and we throw it in Pythagoras' theorem. If we have it in unit vector form, we get the x and the y components and we do the exact same, thus resulting in a length given at the end. If no units are presented, just state units at the end. Alright, now we can do this manually. Let's have a look at how we can automate this with our calculators. So we're going to say up we come to the calculator, and we may choose to clear all our memory. Next, I go to the top menu by clicking escape a few times. I then go map vec by clicking F3. From there, I may have to press F6 or F6 to get into my vector form. I was already there. And then I'm going to put in my vector. Vector A in this instance is going to be a 2x1, and the value is 3, -4. I press escape, escape. Next, I go to options. I then go to map vec by F2. I go across until I find vec. From there, I want to get my magnitude. Now it doesn't state magnitude over here, rather it goes to the non-intuitive. If you go across, says norm. For some reason on this calculator, the magnitude is described as norm. So I put norm. Next I go vec, alpha, and A. Close it off, enter. Notice that my vector size is 5. Similarly, I'm going to do it for vector B. Now, I haven't keyed vector B into my memory yet, but I can go ahead and simply put in the calculation ahead of time. I go escape, escape. I go into map vec. I now key in vector B. It's a 2x1, and it's in unit vector form. The x component's -1. The y component is 3. I go escape, escape, alpha, B. And you can see that it's root 10 units in length. To approximate it, I just press SD. So in summary, what we had a look at in this video was, firstly, what is the magnitude of a vector? That being simply its length. We then had a look at how where the theorem comes from. For finding this, we simply discovered that it's just Pythagoras' theorem repackaged in a different area of mathematics. We use it because the x and y are opposed at 90 degrees, so it forms a triangle. It just works. From there, we had a look at some manual calculations. We had a look at how we can calculate the magnitude of a column vector, also known as component form. And then we had a look at how we can do it with a unit vector. After which, we then looked at how we can utilize technology to automate this for us.